In this video, let us look at different types of matrices. The first type that we're going to look is called a row matrix. What is a row matrix? A row matrix is a matrix which has only one row. Row matrix is a matrix which has only one row. As if a matrix A is a m by n matrix, m is equal to 1 makes it a row matrix. It is a matrix which looks like 1 by n matrix. For example, 1, 2, 1, 5. This is a row matrix. As you can very clearly see, this looks like a row. So the order of this is 1 by 4. So any matrix which has only one row is called a row matrix. And corresponding to row matrix, obviously you'll also have a column matrix. That's the second type. So what is a column matrix? A matrix which has only one column. Whereas a m by 1 matrix is called a column matrix. Or n is equal to 1 mathematically makes it a column matrix. And how does the matrix look like? It now looks like a column. This is a 3 by 1 matrix. It has 3 rows but only 1 column. Such matrices are called column matrices. And the next type is called a zero matrix. Zero matrix. What is the definition of zero matrix? A matrix where all the elements are 0 is called a zero matrix. A m by n matrix such that matrix A m by n such that Aij is equal to 0 for all values of I comma j is called a zero matrix. So you take any element in AMN, it looks like Aij as we have discussed. So every element Aij has to be equal to 0 for all possible values of Img. For example, 0, 0, 0, 0, 0, 0 is a zero matrix of the order 2 by 3. So the first 3 types are very clear. The next type of matrix is called a square matrix. Square matrix. We have already seen what a square matrix is. If A is a m by n matrix, if the number of rows is equal to the number of columns, then it is called a square matrix. That is, m is equal to n. So if m is equal to n, we call it a square matrix. For example, if you have a matrix 1, 2, 1, 3, this is a 2 by 2 matrix, right? 2 rows and 2 columns. So this is an example of a square matrix. It is 2 by 2. The number of rows is same as the number of columns. Or it can be a 3 by 3 matrix. 1, 1, 3, 2, 1, 5, 1, 4, 2. This is a square matrix of the order 2 by 2. Next, square matrix of the order 3 by 3. So the next type of matrix is called a diagonal matrix. Diagonal matrix. So what is a diagonal matrix? A matrix where all the non-diagonal elements are 0 is called a diagonal matrix. We have seen that a diagonal exists for a square matrix, and the diagonal elements are all those elements whose row number is same as the column number. For example, if you have a matrix A which is m by m matrix, that is a square matrix. it has elements of the form AIJ. So what is the mathematical definition of diagonal matrix? All elements apart from the diagonal elements, that is, all non-diagonal elements have to be equal to 0. That is, AIJ has to be 0 for all I not equal to j. We have seen that I is equal to j implies diagonal elements. I not equal to j are all non-diagonal elements. So the definition of diagonal matrix is that all non-diagonal elements have to be equal to 0. The same sentence that I am saying can be mathematically expressed as Aij is equal to 0 for all I not equal to j. For example, if you have a 3 by 3 matrix, 1 0 0 0 5 0 0 0 6. This is a diagonal matrix. As you can see, all the non-diagonal elements are 0, hence the definition is valid. So it is not necessary that the diagonal elements have to be non-zero. So nothing is said about the diagonal elements in the definition of the diagonal matrix. It just says that if the non-diagonal elements are zeros, then it is a diagonal matrix. Sometimes some of the elements of the diagonal can also be 0. What you just need to check is whether the non-diagonal elements is 0 or not. So there is a shortcut to express this matrix. This matrix can also be expressed as diag 1 5 6. That is, this is a diagonal matrix whose diagonal elements in the order are 1, 5 and 6. So if there are 3 diagonal elements, so we can understand that it is a 3 by 3 matrix, and these are the 3 diagonal elements, and all the remaining elements can be put as zeros. So whenever you see diag something, you need to understand that we are talking about a diagonal matrix. Next, you have something called a scalar matrix. A scalar matrix. A scalar matrix is a diagonal matrix where all the diagonal elements are equal. That is, a scalar matrix has to be a diagonal matrix. That is, if A m by m is a square matrix, then Aij has to be equal to 0 for all I not equal to j. That is one condition that needs to be satisfied. Aij is equal to 0 for all I not equal to j. This is one condition. And Aii has to be equal to a particular constant for all possible values of I. So these are the two conditions which needs to be satisfied. For example, if you want a 3 by 3 scalar matrix, so all the diagonal elements have to be same, any particular number. It is 2, 2, 2, for example, and all the remaining elements have to be equal to 0. So it is a diagonal matrix whose diagonal elements are equal. Such matrix is called a scalar matrix. We can see the justification for this name when you deal with matrix multiplication. So this matrix is called a scalar matrix because this matrix behaves like a scalar. That is, behaves like a single number when it comes to the matrix multiplication. So let us see it clearly in the topic of multiplication. For now, scalar matrix is a matrix whose diagonal elements are equal and non-diagonal elements are zeros. The next type of matrix is called an identity matrix. Identity matrix or a unit matrix. Identity matrix or a unit matrix. So now the definition of this is an identity matrix is a scalar matrix whose all diagonal elements are equal to 1. That is, it has to be a scalar matrix. That means it has to be a diagonal matrix. So Aij is equal to 0 for all I not equal to j. This is the first condition. All the non-diagonal elements are zeros. And Aii, if row number is same as column number, that means we are dealing with the diagonal elements. So Aii has to be equal to 1 for all values of I. For a scalar matrix, Aii are equal, but they can be equal to any number. In an identity matrix, all the diagonal elements have to be equal to 1 and all the non-diagonal elements have to be equal to 0. So if you are dealing with a unit matrix of the order 2 by 2, so it will be 1, 1, 0, 0. It's a very particular matrix. So 1, 0, 0, 1 is a unit matrix of the order 2 by 2. And we denote it by I 2 by 2. I 2 by 2. That is identity matrix of the order 2 by 2. So if you have the identity matrix of the order 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So what can this be represented as? I can represent it by I3 by 3 or simply I3 also, because we know that identity matrix has to be a square matrix. So if I write 1, 3, you can understand by yourself that the other number should also be equal to 3. So I2 by 2 can also be written as I2. Identity matrix of the order 2. Defaultly we know that identity matrix is a square matrix. Means the next number is also equal to 2. So we don't need to write it. So whenever you see I2 in the chapter of matrices, you need to understand it as an identity matrix of the order 2 by 2. I3, identity matrix of the order 3 by 3. So you can have identity matrix of any order m by n. The next type of matrix is called a lower triangular matrix. Lower triangular matrix. So what is a lower triangular matrix? A matrix where all the elements in the upper triangle are equal to 0 is called lower triangular matrix. It means if you have a matrix, a square matrix of the order 3 by 3. So if the matrix is something like this: 1, 2, 1, 4, 1, 3, 0, 0, 0. If all the elements in the upper triangle are equal to 0, then we say that the matrix is a lower triangular matrix. So mathematically, Aij has to be equal to 0 for all. So how do we denote the upper triangle? In the upper triangle, the column number is more than row number. That is, Aij has to be 0 for all I less than j. For all I less than j, we have seen that the diagonal elements correspond to I equal to j. The upper triangle elements corresponds to I less than j, and the lower triangle elements corresponds to I greater than j. So if all the upper triangular elements are zeros, then we say that the matrix is a lower triangular matrix. And similarly, the complementary item for this is upper triangular matrix. Upper triangular matrix. So what will be the corresponding definition of upper triangular matrix? If the lower triangular elements are 0, we call it a upper triangular matrix. So the definition of upper triangular matrix is Aij has to be equal to 0 for all I greater than j. So upper triangular matrix implies the lower triangular elements are zeros. Lower triangular matrix implies the upper triangular elements are equal to zeros.